What's up, guys? This is the heat capacity problem. So in this one, the heat capacity as a constant volume, they gave us a value of it, monatomic gas. They gave us to us that's 48.3 joules per Kelvin. So in the first question, they said find the number of moles of the gas. Okay, so we want the number of moles, which is small n. Okay, so the first thing we do is constant volume is equal to the heat divided by the temperature, change in temperature. And then the heat is equal to internal energy, the change in internal energy, minus the work divided by delta T. Okay, but the work here is 0 because it's at constant volume. So if let's say there's some gas in here, this is like piston, and then the gas is pushing up on it, or it's a constant volume, so it's not pushing up. So there's a change in temperature in here, but the gas is not allowed to go up. That means the distance from here to here is 0. The delta x is 0, because we know that work is equal force times distance. Okay, delta distance. So if there is no distance in here, because it's a constant volume, that means it's 0. The work done is 0 by the gas or on the gas. Okay, and then the internal energy, delta U, is equal to 3 divided by 2 n RT. Okay, since it's delta, so it's delta. Okay, so we plug in that in here again. So we do, so CV will be equal to 3 divided by 2 nr, and then you just cross the delta T's out when you plug in this in here. Okay, so this is the first equation. So they want the n, so solving for n is going to be equal to 2/3 CV divided by R. Okay, and R is equal to the 8.314, and CV, they gave it to us. Cool. Alright, number 2 is what is the internal energy of the gas at temperature equal 300 Kelvin. So at temperature equal 300 Kelvin, what we're going to do, we're going to look back at the equation we had in here. Okay, so they're asking about internal energy, and with what we just did in here, CV is going to be equal to delta U divided by delta T. Okay, but since they're asking about what's the internal energy at this certain temperature, that means it's not a change now. So it's going to be U divided by T equals CV. So the internal energy is going to be equal to CV times the temperature T. Okay. Now next question, what's the heat capacity at a constant pressure? So now it's a constant pressure. I'll try to explain it like with variables as best as I can. I just watched Khan Academy's video, so I'll try to link it up in the video so you can guys watch it if you didn't understand me what I was saying. Anyway, so number 3, constant pressure. So we're going to do the same thing, which is Q divided by delta T. Okay, and then Q is going to be equal to change internal energy minus work divided by delta T, change in temperature. So the work in this case is going to have, there's going to be some value for it because it's a constant pressure, but the volume is going to change. Okay, so we'll call this D, and then this is going to be the area that it's going to change. So let's say 1 up here. Okay, so this is the distance, and this is the area. And if you think about it, so work is equal to force times distance. Okay, so also if you can divide this by area times area, okay, A times D, which is volume now, and force divided by area is like pressure. Okay, delta V, because this is delta T, delta D2. Okay, hope this makes sense in here. Cool. Okay. And then the pressure, if you put, okay, let's plug in everything in here. So delta U, we said it was 3/2 nRT. It's called delta T because it's change, minus the work. The work in this case is P delta V, and then all of it's divided by delta T. Okay, so let's change the P. P is equal, so PV is equal to nRT, right? And then it's going to delta V, delta T. So now P is going to be equal to nR delta T divided by delta V. So when you plug in that in here, the V is going to cancel. So now what we have is nR delta T minus, okay, now this whole term is going to be negative because it's moving against this guy in here, okay, against the motion of what it should be. Because if it's adding to it, that means the work is going to be negative, the opposite of what the thing is moving. So it's going to be positive, and then the guy in here is going to be nRT delta T divided by delta T. Now the T is going to drop, so what we end up with is 3 to nR plus nR. Okay, and then so that will add up to 5/2 nR. Okay, so that's the equation for CP. Okay, alright guys, if you have any question, let me know and I'll try to answer it.